Okay, can everyone see the full screen slide?
Yeah, I can see it.
Okay, awesome. Thank you. So my name's Evan Gilman, and I'm a maintainer on the SPIFFE and SPIRE projects. And as Umar mentioned, we got a lot of survey feedback over the last couple of months that people that were joining this meetup kind of wanted to learn a little bit more about how different patterns to deploy SPIRE in production, how to scale it, how to make it highly available, all of that kind of stuff. And so this is a short presentation that I put together to try and answer some of those questions. It's actually a modified excerpt from a KubeCon talk late last year. And unfortunately, we didn't have much time in that talk, so we kind of rushed through this section. So my intention is I went through and modified all the slides, and my intention is to kind of spend a lot more time focused on this specific concepts here. And so my hope is, number one, to cover them in more depth, but also number two, to kind of keep this casual. And if because this is just a meetup and we have a limited number of people, if anyone has any questions, please feel free to call out and interrupt, and we can address them as they come. Okay, so I thought the first thing that would be a good idea to cover is kind of the basic architecture of SPIRE. For those that might not be familiar, we have two major kind of components in SPIRE: a server and an agent. You have this centralized server. All of these agents connect back to this server, and typically you have kind of one agent deployed per node. And all the workloads that you have deployed onto that node, whether that be the software you wrote or whether it be some off-the-shelf software or anything of that nature, they communicate with this local copy of the SPIRE agent, and that's where they pull their identity out. They pull identity and keys for that identity. So, that can be X509 certificates and private keys. It can be JOTs. They also pull out of their information about who they trust. So, the public CA certificates of other SPIFFE trust domains or the local SPIFFE trust domain, and in which cases they should trust those things. And so, the main goal of this, of course, is to enable this kind of workload to workload communication. So when one workload contacts another workload, you have this common basis of trust, and you understand how to validate each other's identities and how to authenticate traffic and all that good stuff. But of course, this is a pretty enabling communication between workloads is a pretty fundamental thing in distributed systems. And so, the next question is always, well, what's up with this? What's up with this SPIRE server? What happens if it goes down? Are you saying if it goes down, all my workloads can't talk to each other anymore? And how do you manage this in real life? So that's the gist of the questions that come up, and what I'm hoping to kind of illustrate today, how we deal with that. So the first and kind of most basic deployment is just a single SPIRE server with some SPIRE agents attached to it. And I think the important part to understand about this architecture and about all of the slides going forward is that as soon as an agent boots up, it asks the server, what identities am I able to issue? The server says, here are the identities that you're authorized for, and the agent will go ahead and create the certs and keys and everything for all of those identities and cache them down in advance. And this also includes if you register an identity with the server after the fact, the agents pick this up and suck those down. So there's a number of reasons why we do that. One of them is performance purposes. When an agent goes and pings the workload and says, hey, I'm here, I need my identity, the identity is already there and ready to go. Another, of course, is availability. So what happens when a single server goes down? In this case, we have this agent cache, which has kind of already been primed up and ready to go. So the agent is still able to serve keys and identities and trust bundles and things like that back to its workloads while the server is down. But an operator cannot like manage those identities while the server is down, because that's typically done through the server. The other thing here is that the agents won't be able to rotate any of the keys and certificates and so on and so forth that they have in their cache. So this brings up like a really important point is that we have this configurable inside SPIRE called TTL, or time to live. And this configurable dictates exactly how long these SVIDs are valid for. And this is kind of a strict trade-off between security and availability, where the longer that you make these keys and certificates valid for, the longer the server can be down and everything can function without a problem. But also, the more likely it is that something gets exfiltrated or is in use that you don't know about, and those kinds of things. That when the TTL gets very, very long, that's when people start wanting to have revocation lists, because what happens if one is compromised? I need to be able to put it on a deny list somehow. And so, the point of having these short TTLs is to try our best to avoid having to have a deny list, because the management and overhead associated with those is pretty high. So this is the condition if you have only one SPIRE server and it's fully down. It's not the end of the world. You have as much time as the TTL effectively, but it's certainly something that you'll want to address fairly quickly. So that's the basic thing. Of course, it's not the greatest thing in the world, and so when you want to handle this scenario and you want to make sure like, hey, how can I have more than one server? Of course, you can do that with SPIRE 2. In fact, you can deploy n number of servers horizontally. There's no real limit to it, other than, I'm sure you'll run into something at some point, but we have people up to 12, 14, 16, 17, 18 servers, and that runs fine. So, you can have as many as you like practically. And the important thing to understand here is that all these SPIRE servers share a database together. And that's the persistence layer is how they coordinate. Each SPIRE server gets its own signing key pairs, and they share the bundle as kind of the union of these signing key pairs as it is stored in the shared data store. Agents additionally have logic inside them to spread their load across all the available SPIRE servers. So they make a DNS lookup and they discover however many SPIRE servers there are. They actually establish a connection with each one of those, and every request they make is load balanced across that set of SPIRE servers. So not only is this a way to address like single point of failure and redundancy concerns, but it's also the primary scaling mechanism in SPIRE. So I have the last bullet point here is that the SPIRE servers are nominally n plus r, where n is the minimum number of SPIRE servers required for the signing load that you incur, and r is the desired redundancy level. The signing load is a function of effectively how many workloads you have, how many SVIDs in your system you have, and also the TTL. So how frequently do we have to renew those things? So in this scenario, if you lose one of these hosts, it's okay, because the agents stripe across them, it's not really a big deal, and you can lose up to that R factor number of servers without any real impact. As soon as you lose enough servers that there's not enough to handle the load any longer, then what you typically see is a degradation of response time, and that's response time in both SVID issuance, so like signing new SVIDs, and also registration operations or anything that utilizes the database, because you may scale for signing purposes because you have a large number of signing operations and your CPU constrained, but depending on your access patterns, you may also scale for database constraint. And of course, if you lose all of these servers at the same time, then the condition is effectively the same as you've lost your single SPIRE server. Everything continues to live, and the agents can serve out their cached information, but your rotations cannot occur, and management of the identities cannot occur. So next we have what we call nested SPIRE servers. And this is effectively kind of like a tree of SPIRE clusters. So you have one, root level SPIRE cluster, if you will, and then you can have multiple levels of SPIRE clusters that span out beneath that one root cluster. And in this configuration, they all share the same root. So the root keys are managed by the top level SPIRE server cluster, the root CAs, if you will. But each lower level of SPIRE cluster has its own local signing keys available to it. And in the case of X509, that's a X509 intermediate CA. And the agents are configured to kind of connect only to the cluster that is local to them. There's a lot of reasons people do this. Some people do it for scale, but oftentimes it's used to manage failure domains. So maybe you have, a nested topology where, you have one SPIRE server cluster in every availability zone, or one SPIRE server cluster in every region. And then you have kind of this global tier of SPIRE servers, which is less utilized, but is the one that ties all the other regions together. And so in these kinds of configurations, you have agents deployed across all of those things, and they connect to their local SPIRE server clusters, which all kind of roll up to this shared root. And so in this topology, the failure mode is if you lose these upstream servers or this global root level cluster, all the downstream local clusters continue to operate normally. You can still create registration entries and manage registration entries against them, introduce new identities and revoke them, and so on and so forth. And they can still rotate their own identities that reside within that local cluster. But what they cannot rotate is their own signing keys. Because in this nested topology, the root authority is the kind of the end-all authority. And so it needs to be up in order for these downstream signing keys to be rotated. So what you end up getting constrained on here is not the TTL of the SVIDs or certs that you're giving to your workloads, but the TTL of these intermediate certificates or these intermediate signing keys that are given to each one of these levels. So again, you have this kind of trade-off, and depending on what you estimate your response time to be, or those kinds of things, you tune these TTLs to give you as much leeway as necessary without giving quite too much. And then the final kind of pattern here is federated SPIRE servers. So this is what was referred to earlier on the call. And this resembles less of a tree and more of kind of like a point-to-point mesh of different SPIRE server clusters. And the difference here is you can see in the diagram, on the left is trust domain foo, and on the right is trust domain bar. And this trust domain concept is a SPIFFE concept. And what it effectively means is that each one of those has their own dedicated root signing keys that are totally separate from any other trust domain. And this forms a fairly strong security boundary. So you see people doing this kind of thing, for instance, like between staging and production, or maybe between regular production and your PCI environment or regulated environment. Things along those lines, or you can even be across companies or across organizations. Anywhere where you have where you want to draw like a strong security boundary. And so the way that this works is that each one of these trust domains has their own root public keys, and they get kind of shared across in this federation relationship with their quote peers. So here you have one deployment on the left, one deployment on the right, and these SPIRE servers talk to each other every now and again, and they swap their root keys periodically. And one thing about SPIRE is that, well, I guess it's more of a SPIRE concept, is that it's been designed to rotate all keys from the root level down. So nothing is quote long-lived in this system. You certainly could configure it to be long-lived, but all of the automation, including root rotation is fully automated. So it's important to kind of have that connection up so that as these root keys rotate, we receive the updates. And as we receive these updates and these root public keys from other trust domains, those things get propagated downwards into agents and eventually into workloads, so that when workloads contact workloads in other trust domains, they already have the CA certs for that trust domain and are able to authenticate those peers without an issue.
Evan, can I just ask a question at this point? The various topologies that you're describing, are these the emergent patterns that we see in deployments, or are these things for which there are recipes? If I want to stand up a deployment that has a particular shape, do I just build that myself, or are there infrastructure as code templates, things that would help me if I was using Kubernetes or whatever to set this up?
That's a great question. So we certainly have examples of different configurations and Kubernetes YAML and things along those lines of how to deploy in these different patterns. I would say that they're kind of both of the things you described. They're both emergent. These are the patterns that people use to build their systems, but they're also core features and functionality. And there's code explicitly in SPIRE to support these kinds of modes of operation. As far as kind of like canned topologies, what I tried to illustrate here on this slide is that you can kind of mix and match these different things. You can have a single SPIRE server cluster federating with a nested SPIRE server deployment. And you can have standalone SPIRE clusters that don't talk to anyone else. And you can have, and so the way that you design this is really kind of a function of where you want to draw your own security boundaries and where your failure domains are and the scale that you're operating at. And I don't know that there's necessarily like a one size fits all in terms of topology for all of those things. However, it is limited to kind of like these three basic building blocks: this end servers, end server cluster, nested server topology, and federation. And so users will kind of like mix and match these different approaches to fall along those boundaries of whatever whatever environment they're working with. Does that?
Okay.
I don't know if that answers.
Yeah, it does. That's great. Thanks.
Sure.
Evan, while mix and match and combinations are certainly possible, oftentimes organizations choose just one, right? Even in very large scale environments.
They may, yes. I think that in a very large scale environment, it is unlikely to not find all three of these somewhere. The degree to which they are kind of mixed and mashed and jumbled up may differ highly. So one organization that, for example, wants to kind of go like the more traditional PKI route, they may wish to go like, hey, we're just going to commit to the nested topology right out, and we're going to have a global layer that handles our root, and that's going to be backed by an HSM. And in every one of our sites or branches or regions or availability zones or what have you, we're going to put a nested SPIRE server cluster, and that's just how we're going to run. Certainly people do that, but also, the same folks probably have a staging environment and other environments which they may want to maintain like separate key material for. And so maybe in that kind of scenario, you end up with like one very large nested deploy or two very large nested deployments, one for production, one for staging. Those two federate, and then that's kind of the end of the day. So the complexity is minimized, but I think it's still pretty common to be leveraging kind of all three in one place or another.
Yeah. And starting off with one doesn't preclude you from bridging onto another.
Oh, right. Absolutely.
If you're doing nested, you can any day turn on the federation endpoint and federate.
Right.
It doesn't stop you from doing that. So these models are very helpful conceptually, but they're not prescriptive, right? You can do any at any point in time.
Yes, exactly. You should think of them kind of like building blocks or Lego blocks, you know. They can be, you can start with one small one or one or two, and you can snap new ones on or remove them, you know, as things evolve and as the deployment grows and all that stuff.
Yeah. Very soft lines and like fungible blocks.
Right.
Cool. Evan, do you have a couple more slides, or we can take
Yes, I
one or
have.
two?
I have 3 more.
Okay.
So the next one here is just talking about kind of what happens, what's the failure mode of this federated SPIRE service pattern. So in this kind of mode, the clusters in the food trust domain, they operate normally. You know, nothing is impairing their operation. They continue to rotate and go along their day. The disruption is really when it comes to like picking up the public keys of your peer, your failed peer. So, you know, authentication still nominally works because you do have the keys, but those keys rotate on some frequency. Maybe it's once a week, maybe it's once a month. You know, typically it's a lot looser than the TTL of a workload SVOD. So the consequence of this is that, you know, you're no longer able to kind of fetch these root key updates from your peer, and so long as they continue using the same key and don't rotate away while you can't communicate with them, everything should be fine. If they do, then what you'll see kind of these transient like cross-domain authentication failures. But usually you have many days, on the orders of, you know, maybe even weeks, to kind of correct a situation like this. So in summary, you know, there are these 3 kind of major deployment patterns that can be mixed and matched however your environment requires. We have this like N SPIRE servers, where N can be 1 or N can be, you know, 24, depending on your needs. We have this nested SPIRE server topology where you can have, you know, these SPIRE server clusters that form a tree and all roll up to kind of a shared root. And then we also have this federated model where you can have a nested or non-nested deployments federate with each other, where public keys are shared between one another, and you authenticate peers in this manner. And the 3 primary things that this will solve for is scale, number 1, like signing load, a number of workloads and different regions, things along those lines. Also the failure domain. So, you know, based on continent, based on locality, could even be based on hardware, you know, different aggregation switches and routers and things along those lines. And finally, the security domains, you know, who gets to control what keys, you know, where do we need to share private keys or not, or don't want to share private keys. And that goes back to kind of like the trust domain federated architecture I described a moment ago. And of course, there's plenty more to learn about all of this stuff. We have a page on the SPIFFE.io website called Scaling SPIRE. If you click through there, you can see a lot of what I described, but in more detail and textual representation. Of course, we have a Slack organization as well. We're very responsive there. If you have any questions, you know, please feel free to join there. Everyone's pretty friendly. And of course, I'm happy to take any questions that y'all might have here before we end this presentation. I see Andres has his hands raised already.
Yeah, thanks, Evan. Great presentation. Very informational. On deployment patterns, is it often assumed that the method to talk to the gRPC API is over Unix domain socket? Can you elaborate a little bit on that, if there are other alternatives?
You're talking about the workload API?
The workload API communication.
Yes. Here.
Correct.
So you're talking about this, right? This workload to SPIRE agent. So right now, in SPIRE, we only support Unix domain socket for this communication. The SPIFFE specification allows this to be done over TCP. However, it's a much more difficult proposition, and it comes with a bunch of trade-offs. We've been looking at it for a number of years to support Inspire. and we haven't due to performance related reasons and also the kinds of privileges that it would require SPIRE agent to have. So right now SPIRE supports only Unix domain socket, but it is possible to support TCP/IP with given the right set of constraints.
Cool. Anyone else with any questions? I think we can take one, maybe more, then we have a couple more speakers. But thank you, Evan, for putting this together. I know this was something brand new, so this will be recorded and posted too. But any other questions from anyone else? This is a great chance.
Evan, this is Madhu.
Yeah.
Yeah, I just had a quick comment actually. Like you mentioned about the N and R, right? Like the maximum number of SPIRE servers and the number of redundancy. So is there some sort of a formal calculator or something where we can, I think it would be useful, just put some numbers and get back those N and R values? Just thoughts there.
That's a good question. Hi, Madhu. It's nice to hear from you.
Hey.
Yeah, I know that on the website we have like this matrix of like, if you have this many workloads and this many agents, then this is the kind of resources that you'll need for SPIRE server. Maybe something similar where, yeah, I think that the each cell on that scaling matrix on the website is N. That's the number of servers that you're going to need to support the load that you have in your environment. So you would probably start with that number, and then R would be, okay, if you want like N+1 or N+2 or N+3, right? R would be that plus value. So if you wanted N+3, for example, and your N from that table was 6, then you'd want 9 servers. But a calculator would be awesome, and I would love
I think it's also, we have to include the TTLs in that function, right? Like the workloads, the number of workloads, and just a comment there, really.
Yes, totally. I would love to see something like that on the website maybe one day. That would be great. Some sliders and stuff.
Yeah.
Great. Thanks, Evan, for the presentation. I'm sure people can Slack you on the SPIFFE Slack channel too. I think everyone is there. But again, thank you so much for the time and effort you put into this. This is definitely useful. With